Hi friends, this is Prasad. Today we are discussing the interior structure of Earth. If you understand Earth structure, you can easily understand the volcanoes, earthquake formation, landform formation and soil formation. All are geomorphology topics, easily understand. So first understand the basic structure of the Earth interior. Today we will discuss the first what is the basic structure of the Earth interior and the evidences support the prediction of Earth's interior and the finally overall view of the Earth structure. So today our lecture plan, first basic structure of the Earth interior. You know basic structure of Earth interior. This is the Earth. This is the crust, Earth crust, mantle, and core. We know basic structure of the Earth. This is the crust. Crust is the two types of crust, oceanic crust and continent crust. Continent crust and oceanic crust. Mantle is the two types, upper mantle and lower mantle. Upper and lower. Again core is the two types, outer core and inner core. Outer core, inner core. Inner core. We know basic structure. Earth containing the three layers. This is the first layer is the crust, second layer is mantle, and the last layer is the core. Crust containing silica, aluminum, Cl, mantle containing silica, magnesium, and the core containing nickel and ferrous, knife. So this is the overall view, is the cross section of the Earth structure. This is the crust, mantle and the core. You know, crust containing the silica, aluminum elements and mantle containing silica, magnesium and the core containing nickel and ferrous. Okay, what is the basic structure? We understand the basic structure. After evidences, we can clearly understand the overall view of the Earth structure. What is the basic structure? We know Earth containing crust and the below the crust mantle. Below the mantle is called core. Okay. Next, this is the continental and oceanic crust is the solid part, solid state, and upper mantle upper mantle of the some part is called asthenosphere. It is the semi-liquid state. Semi-liquid state, and the lower mantle is the solid. Outer core is the liquid state. Outer core is the liquid state. Inner core is solid state. Outer core of the Earth is the liquid state. Inner core of the Earth solid state. Okay. The width of the average width of the continent crust is 30 kilometers and oceanic crust is 5 kilometers. Okay. The basics, the depth Okay, cross section view of the earth structure. This is the radius of the earth is equal to 6,370 kilometers. 6,370 kilometers. Okay, the outer core containing the 2,900 kilometers. Outer core to lower mantle. The border between the mantle and the core is 2,900. Okay, the radius of the earth is equal to 6,370 kilometers. So we know basic idea of the earth. Earth containing 3 layers. Okay, different layers containing the different elements, and the okay, what is the nature of the state, either solid or liquid also we know, basic understand. Okay, first we can't directly enter from earth surface to earth interior 3 to 4 kilometers directly from the earth surface to below the earth interior. We can't possible to dig or mining the earth interior maximum 3 to 4 kilometers digging up the directly, or mining 10 to 12 kilometers we can enter. But how can predict the earth structure, earth containing the upper mantle containing semi-liquid state, outer core is the range 2,900 kilometers after outer core containing the liquid state, and the different layers of chemical composition. How can we now what is the basic evidences to support the earth structure? What is the evidences? So friends, we can't dig directly to 3 to 4 kilometers from earth interior. How can possible chemical composition, nature of the state of the different layers? So basic evidences to support the earth interior. So we discuss the basic evidences to predict the earth structure. Okay. Basic evidences, two types: direct evidences and indirect evidences to support the earth structure. Evidences is two types based on source: direct and indirect. Indirect evidences. Okay friends, direct evidences are digging, mining, or drilling, mining, and meteors. Drilling, mining, meteors. Third, volcanoes. These are the direct evidences. These are the important direct evidences. Many drilling, meteors, and volcanoes are the direct evidences. Indirect evidences are density, pressure, temperature and gravity, gravity, and finally seismic activity. Seismic activity. Indirect evidences, seismic activity. Seismic indirect evidences, seismic activity is the important source for prediction of Earth interior. And the direct source, volcanoes are the very important for prediction of Earth structure. These are the basic source to observe the what is the characters, what is the characters of the Earth interior. We can discuss individually one by one. Okay. Every characters to show one or two characters of the Earth structure. Maybe this is a chemical composition, what is the pressure, what is the temperature. We are going to a surface to Earth interior. Temperature also increases, pressure increases, density increases. Why increases pressure and density? Why 6000 Celsius temperature in the Earth interior? Why increases the temperature? What is this is the basic evidences. Basic evidences support the. Okay. Drilling and mining. First one is direct sources, drilling and mining. Earth interior we can't directly enter into the drill the Earth interior. We can drill only 3 to 4 kilometers drilling. In case of mining, 10 to 12 kilometers. Drilling is the integrated oceanic drilling project, and okay, different drilling projects. We can directly enter into the Earth interior. Drilling, if you drill the Earth crust, we can directly enter into the 3 to 4 kilometers. If you dig every 100 meters, if you enter from surface to Earth interior, every 100 meters, temperature increases 2 to 3 degrees Celsius. 2 to 3 degrees Celsius temperature increases. This shows every 100 meters. This is not a some areas temperature increases so high when compared to some areas. It is not a constant to every place increases the 100 meters 2 to 3 degrees, not a 2 3 degrees. Some areas increases high temperature, some areas low. But if you enter into the Earth surface to interior, every 100 meters 2 to 3 degrees centigrade Celsius increases. Digging and why increases, discuss the next. Okay, drilling and mining at the interior containing the high temperatures, 6700 degrees Celsius temperature, high temperature, and then also some chemical composition of the Earth structure. We know Earth structure. Okay, drilling and mining. Next, meteors. This is not a part of Earth interior. It is the outer part of Earth, but it is similarly shape of the Earth structure. The meteors also containing two parts. Inner part containing nickel and ferrous. Outer part containing the lighter components. So maybe it is similar to Earth structure. Maybe our Earth containing inner core containing nickel and ferrous. Okay, this is the meteors helps the similar to Earth structure. Next, volcanoes. Volcanoes and seismic activity. We are big topics we have discussed next video. So first we know what is the volcanoes used to predict what is the use of the predict the Earth structure. Volcanoes are the important source, direct source prediction of the Earth structure. Okay, volcanoes coming material. This is the the crust, at the core. This is the upper mantle, upper mantle asthenosphere, upper mantle asthenosphere, upper mantle asthenosphere, crust, upper mantle asthenosphere, lower mantle, and the core. Volcanoes, when we erupt the volcano, this coming material from 100 to 700 kilometers from the depth. Coming material from 100 to 700 kilometers depth of the upper mantle. So we can easily analyze these components. What is the chemical nature? We know already discussed. Crust containing Cl and mantle containing silica and magnesium. Different chemical composition containing the earth. Not only chemical composition containing the earth layers, but also earth is not a homogeneous layer. Earth is the heterogeneous layer. So what is the homogeneous layer, heterogeneous layer? Homogeneous means complete earth is the solid state. That is called homogeneous layer. Earth is containing not a homogeneous, some liquid layer, liquid or semi-solid layer in the earth interior. We know what is how to know this solid, semi-solid or liquid nature in the earth interior. Volcanoes coming same. If you erupt the volcanoes, a lot of gases, semi-solid particles, liquid coming from 100 to 700 kilometers depth. This shows maybe earth containing some liquid layer in the earth interior. Okay, we can't directly dig the 3 to 4 kilometers. Volcanoes helps to easily analyze the material composition of the earth layers. This is helps for the prediction of earth structure. We can discuss the indirect sources. Indirect sources. First we discuss the one by one. Density. What is density means? What is density? In the earth containing different layers, different densities. Suppose this is the earth containing, crust containing 2.7, mantle containing 3, and the core containing 11 grams per centimeter cube. 11 grams per centimeter cube. Different layers. Overall earth containing 5 grams per centimeter cube. This is the density. Why increases the density from crust to core? Why increases the density? What is density? Density means mass by volume. How much of mass containing volume? Certain volume. If you take some cubic meter, how much of the mass, how much of weight? So suppose this material containing the 2 grams, this material containing 3 grams, this material containing 11 grams. Which material is heavy weight? This material containing heavy weight. So core material containing the heavy weight. So if you this is the density. If you increases the density, automatically rises the pressure. Why increases the density with depth of the interior? Two reasons. Chemical composition and the incumbrant load of the material. So what is the chemical composition? Chemical composition also rises the density directly raises the density. You know, earth crust containing silica, aluminum, Cl. Earth crust containing the Cl. Earth crust containing Cl, earth mantle containing CMA, silica, magnesium. This is the knife. This element composition also directly raises the density. Okay, silica aluminum is the lesser elements when compared to silica magnesium. Silica magnesium is the lesser weight when compared to the nickel ferrous. So the chemical composition also directly raises the density. Okay, chemical composition is the one, and the second one is every load also. So this component's load increases with depth. Suppose crust containing some piece of the earth structure, crust containing some weight. This weight plus the mantle weight, so double the weight, and the complete load of the material, encumbrant load of the material also compress the material and also increases the density. So high density source automatically rise the pressure. Pressure and the density also rises when increases the depth, increases the density of the material, and increases the pressure of the depth, also rises the heavy temperature also increases. Okay, density, pressure, and temperature. Okay, next we understand what is the gravity. Gravity used to analyze the earth structure. What is the gravity? Suppose this is a earth, pole, equator, and poles. Which region having a highest gravity? Either poles or equator. Equator containing low gravity. Why space stations are located near the equator, not poles? Because of high gravity. Why the gravity? What is the gravity of the earth? Because of molten material. This is the molten material give the gravity. This is the molten material. So the molten material and the poles distance is the less. So this is high gravity on the poles. High gravity in poles, and the distance from the earth equator to earth molten material from the earth interior. So distance between this region is high, so gravity is low gravity. Poles containing the molten material and earth surface is the decreases, so gravity will be high. This shows earth interior containing the high distance from the earth surface. Okay, so maybe many space stations are near the earth equator. Okay, next important indirect source for earth prediction of earth structure is seismic activity. Okay, discuss the seismic activity. Okay, friends. Seismic activity. Seismic waves. Seismic waves are generated on the earthquake. When occur the earthquake, seismic waves are generated. Seismic waves are two types: body waves and surface waves. Body waves and surface waves. surface waves. Body waves are two types, P waves and S waves. P waves and S waves are called as body waves. Why P waves and S waves are called body waves? Because of when happening in the earthquake, P waves and S waves travel whole body of earth. So this is called body waves. P waves and S waves travel both body means, what is the word body? Word body means earth, crust, mantle, core. These three layers travel the P waves and S waves called body waves, whole earth body. So surface waves are generated on earth surface only. So this is called surface wave. This is called body waves because of earth body. It is passes through both crust, mantle and core, and again mantle, crust. So this is called P waves and S waves are called as body waves. Important one, P waves and S waves characters. It is very important for P waves and S waves character. If you know P waves and S waves basic characters, P waves and S wave characters are used to predict the earth interior. P waves are similar to sound waves. These are the S waves are similar to light waves, sound waves and light waves. These are the P waves are travel to both solid, liquid and gases. S waves are important. S waves have important property. It passes only solids. Only solids. P waves are faster than the light waves. P waves velocity higher than S waves. Okay, first you reach the P waves, after reach S waves. Okay, the velocity of the P waves different medium like solid and liquid. Solid is high when compared to liquid. Liquid is high when compared to gases. P waves travels both solid, liquid and gases, but velocity changes. It changes the medium. Solid medium P waves faster when compared to liquid medium, and liquid medium when compared to gases. Why solid liquid means our earth containing our earth outer core containing liquid, earth upper mantle containing semi-solid. So we discuss later how to use this P waves and S waves. Okay, this is the basic characters. This is move both solid and liquid. S waves move only solid, but velocity changes from solid to liquid medium. And also P waves are higher velocity when compared to S waves. If you happen the earthquake, if you stand on here, if you happen the earthquake, you first reaches the which waves? P waves. Why P waves reached the? P waves are highest velocity when compared to S waves. First it reaches the P waves, next reaches the S waves, and next reaches the surface wave. Which is most disasterable waves? S waves. It is responsible for more disaster. Okay, it is responsible for more disaster. P waves are the longitudinal waves. It is the parallel to the earth structure. It is the transitional. It is the perpendicular to earth structure. This is the distortional waves, highly distortional. It is a major responsible for disaster. Okay, we use the seismographs to predict the earth structure. These characters. Different seismographs individually, P waves and S waves. Seismographs individually, seismographs different. Okay, before seismographs, we know what is the basic understanding of the seismographs and the focus point and hypocenter. Origin of earthquake, this point is called focus point. Focus or hypocenter. Exact surface are perpendicular to the line of the above the point is epicenter. We draw the lines from the, suppose we take the epicenter, so P waves graphs, P waves seismic graph, P waves seismic graph. We have origin point of the, this is the exact surface of the focus point. Suppose origin of the earthquake, we draw the lines from the epicenter. Okay, this is the concave shape of the lines. Why concave shape? Why straight? Because of this generation of the waves happening the reflection and refraction. It means reflection means, and the refraction means when the changes medium and the slightly bend. So these lines are the concave shape. This is the P wave seismic graph. Okay, 105 degrees centigrade to 105 to 145 degrees, 105 degrees to 145 degrees range. S waves are P waves are absent. Okay, next we discuss the first P waves also. After finally discuss how to use this structure to predict the earth structure. Okay. This is the earth core. S waves, seismic graph. Okay, earthquake is the epicenter. We draw the lines from the okay, 105 degrees. Every region have this is the seismic detectors. These are the seismic wave detectors. Detect the S waves only on this region. Beyond this 105 degrees, absence of S waves. Why absence of S waves in this region? Why only S waves detect the origin point from the epicenter to 105 degrees only? Why absent beyond the 105 degrees? Because of S waves S waves have important character. It travels only solid medium, not liquid or gases. Because of this is the earth outer core. Earth outer core containing liquid nature. Earth outer core is the liquid nature. So S waves cannot travel the liquid. So seismic wave detectors cannot detect this region. So 105 degrees the S waves are touches the outer core absence of the entire region. This is called shadow zone of S waves. Shadow zone of S waves. Okay. This S wave seismograph used to earth outer core containing liquid state. Okay, how to use the P waves seismograph to prediction of the earth structure? Because of P waves have important property. P waves it is moved both solid, liquid and gases. When velocity changes from density also increases, means it will be high density, the velocity also increases. Okay, solid when compared to liquid, solid is the high velocity, and compared to liquid, gases is the less velocity. So in the earth surface to earth interior, density also rises. We already discussed earth core containing 11 grams per, and the overall average of the earth core containing 11 grams per centimeter cube density, high density. So the velocity also rises when enter into the core. Okay, if you touch the liquid part, the velocity of the P waves decreases. If you enter into the high medium, it means enter into the different mediums. It's not only mediums. The earth 3 layers are the different layers, different mediums, like solid medium, liquid medium and solid medium. If you touches the solid medium, the velocity rises the high velocity. If it touches the liquid, the velocity also reduces. So P waves are used. This is the earth, suppose earth origin point. This is the crust. When entering to the mantle, P waves velocity highest. When P waves enter into the outer core, velocity decreases. Outer core. When enter into the earth core, velocity rises. Suppose if you take earth crust, this is the earth crust. The only velocity is the how much? 5 to 6 kilometer per second. If you enter into the mantle, okay, rises the velocity, and enter into the outer core, velocity also reduces. If you enter into the core, velocity again increases. Suppose 9 to 12 kilometers per second. So why increases the velocity? Because of high density in the core. Okay, friend. This is the overall view and the evidences of the prediction of earth structure. If you just a few minutes, and it's overall view of the earth structure. Overall view of the earth structure. Just 1-2 minutes completed. Okay. This is the continental crust and this is the oceanic crust. This part is the crust. This part is the mantle. This part is the core. We now already discussed the This is the continental crust and this is the oceanic crust. Continental crust is the thicker but lighter weight. Oceanic crust is the thinner but lighter weight. Continental crust is two types, continent and oceanic. Continental crust is the average thickness is the 30 kilometers. Oceanic crust 5 kilometers. 5 kilometers. But weight of the material is the weight of the which is the heavy weight, continent or ocean. Ocean is the heavy weight. Why? Because heavy weight of the oceanic plate, because of silica and magnesium. Heavy weight minerals containing silica and magnesium. Okay. This is the 100 to 2900. This is the 6370. Okay, not shown there. The core radius is 6370 kilometers in the earth interior. Okay. The mantle, some portion of the upper mantle containing semi-solid states. Some portion of the upper mantle is called semi-solid states. This semi-solid states is containing the soft rocks. It is the semi-solid states. When you erupt, when the breaking of the earth crust, these semi-solid materials come out from this upper mantle, enter into the earth surface. So we call as volcanoes. These are the molten materials. Molten semi-solid. Why semi-solid? It is containing the soft rocks. Okay, this is called asthenosphere. Asthenosphere. Okay, mantle, and the core containing two parts. This is upper mantle containing upper mantle, upper and lower. Core containing two parts, outer core, outer and inner. Okay, this is the layers. Okay, the mantle and the crust, the boundary layer is Moho discontinuity, and the mantle and the core Gutenberg discontinuity. Gutenberg discontinuity, and the okay, in the outer core and the inner core is called Lehman discontinuity. Lehman discontinuity. Okay, friends, this is the overall view of the earth structure. We discussed the basic structure and the evidences support the earth structure and the overall view of the earth structure. In next classes discuss the continental drift theory and plate tectonics. We discuss. Thank you, friends.